Alright, so once the machine boots up, you're going to see this screen. I guess maybe you can read that. So the first step, drives are off, 7 to enable drives. Air is turned on, so we have no low air pressure warning. And the next thing you gotta do is home the axes, and that is 8 either. Keypad, number pad, and then it's gonna ask you to confirm, hit any key. Gonna go Z first. Then it's gonna home Y. And of course, lastly will be X. Now one problem I've seen with these machines, the limit switches can get sticky. They're kind of a pain to take apart and clean, but you can do it. Polish the contacts and it should home successfully. And it will stop. It looks like it's going to run off the table, but we just wait. Okay, so this is saying, hey, there's no floppy in the drive. I can't find the last program that you loaded. No big deal. We'll escape. Same error, escape again. So first thing I like to do is F3 setup, 3 jog. By default, you're set to X. So I'll run it this way just to kind of center things up. I'll grab 4, Y, maybe a little X again. And that is a very quick rundown on the boot up procedure to get ready. From here, you would load your stock, load your part, clamp it to the table, put it in the vise, and load your program and cut. Okay, so now we have powered the machine on, enabled the drives, homed the axes. So at this point I've got the part clamped down, or the stock clamped down, ready to go, and we need to load the program. So this machine's been converted to a floppy emulator by these people, but the steps are still the same. The machine still sees this as a floppy drive assigned letter A. Alright, so we F7, load the program, escape twice. That'll take us to the path field, enter A, and again, and then we drive to the file we want. It'll ask us if you want to overwrite or load it, and you say yes. Alright, so there is our program loaded. Alright, from here, you go to the run menu, F4, auto, key 1, and then we're ready to go. So we've got start here. So it's this switch rotated in a clockwise fashion. And the first thing it's going to do when I hit start is ask me to load the right tool. I've already got tool number 12 in here, ready to go, but we'll go ahead and, right, so begin the tool list, number 12. So again, that tool is already in the machine, ready to go, so I'll hit start again, and then it'll ask to enable the spindle. And on these machines, you got to use both switches. So we want high and then spindle enable. So this one clockwise, the bottom one counterclockwise. High and enable. Alright. And from there, if I hit start again, it should start executing the program. So let's cruise out. professionally pan over some to where we can see. And I have yet to run this program. I'm not positive my clamps are out of the way, but I guess we'll find out together here. So I'm going to set the coolant up, get that spray going, hit the start button one last time and see what happens. Alright, so I'm going to make a quick adjustment with the feed override. So I'm going to hit the 3. That will enable me to drive the feed rate down because I guess I'm a big chicken. So what I did there was hit the hold button to pause the program. Because if you hit either E-stop, the machine will stop, of course, but the program is interrupted and you got to restart from the beginning. So if you need to do something, blow some chips, make sure everything's clear, hit the hold button, and then just to resume, it's a matter of hitting the same start rotation again. Again, just checking, making sure I'm not about to do something crazy. Apparently I had a wrench set when I didn't really mean to have a wrench set. The rest of machining this part was pretty boring, so here's a screenshot of the CAD model. Sorry this demo was missing the program creation, but there are endless ways to create G-code, and I'm not positive that my method and tools would be super helpful. But for anyone curious, I have been using Visual Cam for a few years now. However, I am working on a larger project that is requiring more extensive machining, and I'm planning to cover the rest of the steps not covered in this video in a future video. And those are steps like setting the machine's clear point for tool changes, matching the work zero in the program with the stock or part on the table, and checking and setting tool heights or tool offsets. And finally, for the previously mentioned project, here is one side plate that will be part of a new link required. This part is about 16 inches wide and 3/4 inch thick steel, and is definitely one of the biggest parts I've machined on the V2XT. And as always, thanks for watching.